Alright, so this video is going to be on graphing sine functions, and it's going to be my first video of about 3 or 4 of them, and I'm just going to talk a lot about sine functions, their basics, and so I'm going to start with amplitude and reflections, and that's going to be the basics. So if you've already seen this video or you already know about, check out my other videos on graphing sine functions, but here we go, let's get started. So my function here that I'm going to work with is y equals sine of x. If this is the first time you've ever heard of the trig function sine, you should probably not watch this video. But if you've worked with trig functions before, you've done maybe the unit circle and evaluated trig functions, your next step might be to graph. And so this is how you're going to come up with the graph of y equals sine of x. And so I'm just going to take my x values and I'm going to plug them in like we would normally. So the sine of 0 is 0. The sine of pi halves is 1. The sine of pi is 0. The sine of 3 pi halves is negative 1. And the sine of 2 pi is 0. And so what we're doing is we're just traveling along the unit circle. So if I'm starting at 0, and then here's pi halves, and there's pi, and 3 pi halves, and 2 pi all the way around, all we've really done is just made a journey around the unit circle, and we've ended m1 full revolution. Now we could keep going, but then we would just be finding more points. But we only need those 5 points for now. So I'm going to actually take those and I'm going to plot them, and I'm going to make some notches on my coordinate plane here, and I'm going to space it out by 2s. Not for any mathematical reason other than it just looks nicer. And so here we go. I'm going to label my x-axis because normally our x-axis, if you were to just leave it alone, you would anticipate that it's just being spaced out by 1, 2, 3, 4, 5. But in this case, it's not. So this x value here, and I'm going to write it down below so it doesn't get my way, this x value is 0. The next one is pi halves. The next one is pi. The next one is 3 pi halves. And then the final one is 2 pi. Okay? And so I'm going to plot my points now that we have them. And so here we go. Your first point was at 0, 0. Next point was at pi halves 1. Pi 0. 3 pi halves negative 1. And then 2 pi. And it's at 0. So a sine curve looks like this. Sorry for the wobbliness. But if you think about it, in the first quadrant, between 0 and 2 pi, the y values, or the sine values in the unit circle, are positive in the first and also in the second quadrant as it moves along. And then in the third quadrant, which would be between pi and 3 pi halves, and 3 pi halves to 2 pi, that part would be negative. And so it kind of makes sense that the graph would do that. The highest value the sine could equal is 1, and the lowest value it could equal is negative 1. And so this is what we would call one period of a sine function. Would go from 0 to 2 pi. So a sine function has a period of 0 to 2 pi, and so we would just say it as a period of 2 pi. And you can keep making more points because you could rotate in a counterclockwise direction. So you could call this clockwise direction, negative pi halves. This would be negative pi, and this would be negative 3 pi halves, and this would be negative 2 pi. You might say to yourself, so do I have to plug all those in? And the reality is actually no, you don't. You just need to learn the pattern of the sine function. So this would just keep going with the trend. It would go down, and then back up, and then up, and then back down. And so if I go backwards, that would be the same shape as before, and it just replicates the same image as you go from period to period. So if you wanted to keep going to the right, you could go from 2 pi, and then the next one would end at 4 pi. And you could then make another 5 points. So it'd start in the middle, it would go up, down, down, and then up again. A couple things about the sine function that you might want to notice. The domain here, the graph does keep going on. So the domain would be all real numbers. And the range here would be from negative 1 with a bracket to positive 1. Okay? And so that is your basic sine function. Now let me break down a couple things for you before we move forward. A sine function has this middle to the graph. If you notice, it's got this middle line, and that's where the graph, right, is going to be equally above that middle line and equally below that middle line. And a part of this graph would be this line that goes from here to here. This height right there is called the amplitude. And every sine and cosine, for that matter, have an amplitude, and that also would be considered the amplitude, how far it goes down. And so today, for the rest of the video, I'm going to talk about what does it do to the graph if you change the amplitude. Also, you can picture if there were a reflection over the x-axis, rather than going up first, the graph will go down first from 0, 0. But let's get going. So what am I going to look at in this video? I'm going to look at this guy right here. A changes the amplitude. So if A is 1, then the amplitude is 1. If A is 2, then the amplitude's 2. If A is 3, the amplitude's 3. There's a direct correlation to whatever A is, that's going to be the amplitude. That's how high the graph will go up and how low the graph will go down from the middle. The next thing is that if A is negative, less than 0, then it is a reflection over the x-axis. Okay, and you can see video number 2 for this guy, and you can see video number 3 for this guy. Actually, just kidding, you can see video number 3 for this guy, and you can see video number 4 for this guy. So I'll have 4 videos and kind of breaking down each piece, and I'll kind of build off of it. So if you go in order, you'll kind of learn all the different transformations that go from there. So let's get after it. Here we go. We have the function f of x equals 3 sine of x. So first thing I tell people to do is I tell them to break it down. So if you break it down correctly, you would say that the amplitude is the coefficient of the sine, so it would be 3. And once again, what that means is if that's the middle of our graph, it's going to go up 3 units above and down 3 units below. So you have 3 units here and 3 units there. Okay, our period's still the same. Period is 2 pi. You might say, why do I ask that? Well, I want to know where the graph starts and ends. And so I know all sine functions, if there's no horizontal shift, will start at 0. And if I know the period, then I know where it will end, because I can just add the period, and that would be 2 pi. And then I can find the rest of my points in between. But they're going to be the same as the ones up above, because we haven't changed the period. And then finally, there's no vertical shift or anything like that, so we're good to go. So I'm going to make this a little bit bigger, and then I'm going to draw in my x values so I can label that so you can see where those are. I'm going to go by 2s or 2 blocks on my y-axis as well. And so there we have it. So this is going to be 0. This is going to be pi halves. This is going to be pi, 3 pi halves, and 2 pi. And then we have negative pi halves, negative pi, negative 3 pi halves, and negative 2 pi. So our middle line, right, once again, of this is going to be at the x-axis, and we're going to draw now our graph. And so here we go. It's going to start always at the middle line. So if 0 is your starting point, this is going to start at 0, 0 on the middle line. Then you're going to go up the amplitude, which is 3, right? Got to make one more notch here. 3. So I'm going there, and we've got 3, down 3, down 3 here. Oh, my notch is off, guys. Should have told me. Alright, and then one last one. We've got the graph here. So when you change the amplitude, wow, it's hard to get that all nice. When you change the amplitude, you are doing what we call a vertical stretch, and the graph is now getting higher above the midline and lower, so you're kind of stretching it at both ends. And you can keep making more points if you follow the pattern. Do your best to make it kind of curvy and nice. And then if your teacher asks for the domain, remember the domain of a sine function is all real numbers. And then the range is how far low the graph goes to how far up the graph goes. So the graph goes to -3. So I'm going to use a bracket, -3. And the highest it goes is +3. And I'll use another bracket. Okay. Let's do one where there's a reflection, and hopefully that will kind of complete this and it'll make sense. So you've got yourself an amplitude, which is always positive. In this problem, graph the function y equals -2 sine of x. The amplitude is always positive, and so that's going to be an amplitude of 2. What I then do is I remind myself that there's going to be a reflection, and it's going to be over the x-axis. And then my period is still 2 pi. So one more time, if your period's 2 pi and it's a sine function, you're starting at 0 on the x-axis, and then you're going to 2 pi. And your 5 points should go from 0 to 2 pi, and you can find points that way. If you forget what these points are, you can think about, well, what's at the middle between 0 and 2 pi? That would be pi. What's in the middle of 0 and pi? That would be pi halves. And what's in the middle from pi to 2 pi? That would be 3 pi halves. And that's how you can kind of get your x-axis and know where your points are going to be, because the points should be equidistant from one another. So one more time. 1, 2, 3, 4. 1, 2, 1, 2, 1. All right, and so then from there, we can label our axes and we can graph it. Go ahead and take a moment to do that as I do it as well. Okay, so I've got my axes labeled. I've got everything ready to go. So I just want to talk about real quickly. Notice we have our reflection here, right? And so if I want to do the actual reflection, then what I'm going to do on the graph is, rather than I'm still going to start at my middle line, which has no vertical shift, so it's still at y equals 0. But what I'm going to do from there is I'm going to start at the middle, and instead of going up the amplitude, I'm going to go down the amplitude. So our amplitude is 2, so I'm going to go down 2 and then up 2 and do it that way. So I'll basically reverse the process, and then we can keep going. Alright, and you can do the domain and range. If you wanted, you could keep graphing more periods, but that's how you graph a sine function, and that's how you adjust the amplitude and account for a reflection over the x-axis. Alright, have a great day, and I'll talk to you soon.